Oh my God. Alan, you know where the bridge is?
Yes, I do.
You're the only person I know that knows where the bridge is.
Used to bicycle across it.
Okay, well, I'm going to try to do the last verse. I know you probably only have the first two verses up there.
As a former New Yorker, I know that bridge also.
You know the bridge?
Oh, yeah.
It's 59th Street.
Hi, Randy. Hi, Ed.
Glenn,
Yes.
do you know what the latency time is in terms of milliseconds?
I think it's 17.36.
I knew you'd know.
No, that's
37.
oh shoot.
I was
made that up.
I totally made it up.
I think the latency you get will depend on your own individual driving habits and your own broadband and your own.
Exactly. Yeah. It's so many variables. That's why I made up an answer.
I've got
Yeah, but the 4 digits of precision was really convincing, Glenn.
Yeah, I'm
I
used
do
to
have
that.
to give
Again,
Michael a real credit though. Last night he barged into Carolyn Schutz's birthday party Zoom and offered up a birthday serenade personalized for Carolyn. So it was really cool.
A little latency though.
What a guy.
oh, there's Norm. Hi, Norm. And Helen Gladden is back. Hi, Helen. And Ted Michaels. I didn't say hi to Ted.
Quick background check on Coyle's part again. Can you see the Rotary sign in the virtual background?
Yes.
I can see it, I just can't read it.
No worry. That's all right. Thanks.
And Chuck Hartwig is on. Hi, Chuck. Don taking pictures. That's really quite a.
Yeah. Hey, Pat, say something so your picture comes up. Pat Coyle.
Easy for you to say.
Okay, I got you as your sign.
Dangerous sounds. Sound like somebody pitched over.
Helen Gladden.
Yes.
Is my daughter at work today?
I hope so. I hope so. We love your daughter.
Thank you. So do
We also love Mr. Nebo's daughter.
I. Thank you.
Miss anybody's daughter?
Hey, Michael, where's that background?
In Botswana.
Botswana.
That was like our last day at a sundowner. So it's an appropriate picture.
Yeah, yeah.
Okay, I put you on there, but I don't know what you did.
May I speak a little bit? I was trying to talk and I was muted. That didn't help. Well, first of all, my daughter's 3 months pregnant again.
Oh, congrats.
Yeah. Well, she lost the baby, so this is very exciting for us. And she had
what's causing it
yesterday, and everything's good. And I'm moving up to Washington, to Spokane, Washington, mid-June. I don't know if anybody else had heard that, but I just want to let you know that I'm moving on. I'm going to move back to my family, and my niece Danielle and her husband Steve Gord are going to rent the house. And I'll leave Dad in good.
We've been delighted to have you, Jean. You've made such a wonderful, wonderful difference in your dad's life, and
Thank you.
it's fun to have you at Rotary. We'll wish you well.
Morning, all.
Thank
I
you.
see.
It was just terrific that Danielle is
Why
and
can't I
Porter
hear you?
gonna be in
Oh, I
the
know.
place.
That's a dream come true to live in this house. So that's wonderful. She'll take good care of it. And I've got 2 good caregivers attending to Dad. There you are, Pop. Yeah, so he'll be in good hands. And of course, I got the rest of the family. My sister up in Tahoe, and then my other sister just came back from Baja. She's up in the Carson City area. So everybody's gonna step in where I leave off, but I'll still have feet on the ground down here for quite a while as I, well, especially you can do everything online, right? So I'm just a phone call away, but I just want to share that with everybody. I was going to try and get out mid-May, but I postponed it another month. I thought that was prudent time.
Well,
but-
Jean, I want to say thank you as well. And I also want to tell you that Danielle used to live next door to us. She
That's
and
right,
Steve,
yeah.
and we still miss them. We really miss them. And I know she's been a wonderful granddaughter to John, and that you're leaving her. And I'm so happy they're living in the going to live in the house.
Oh, it's perfect because they
They
were looking at the same time. It's just all laid out real good, Kathy. And God led me here, and He's leading the way. It's the right time. My daughter got pregnant again, and the baby's healthy so far. And last year was really tough. She lost the baby in April. It's almost been a year. So.
Hey, Shay, could you do an audio test, please?
Can you hear me now?
Yes,
I can hear-
you're on. Good. Okay. All right, I think we're close to the transition time here to get started. So this has been nice to have an unformatted 30 minutes, but why don't we take it away with Alan Frank doing the projecting and Jay speaking. And if everybody could mute during this time, just keeps it a little bit easier.
All righty, are we ready to go? Well, if you can see it, it's not the rotary bell. This is a low budget operation, but we're in session. Rotary Club of Livermore. Okay, let's see, the Pledge of Allegiance. I completely forgot to think of a veteran, a victim for this. Jack Mills, how about you lead us in the pledge? Can you unmute your phone and lead us?
Okay, everybody ready? Face the flag.
Yep.
I pledge allegiance to the flag of the United States of America and to the republic and one nation, God, indivisible, with liberty and justice for all.
Thank you. Michael.
Is it my turn? Can you hear me okay?
Yeah.
Okay.
Pull back, Alan. Pull back. Jump the gun.
I have to slow down. Slow down, you move too fast. You've got to make the morning last. Kicking down cobblestone. Looking for fun and feeling groovy. Okay, now we got a little bit of delay. Okay. Hello, lamppost. What you going? I come to watch the flowers growing. Ain't you got no rhymes for me? I got no deeds to do, no promises to keep. I'm dappled and drowsy and ready to sleep. Let the morning time drop all its petals on me. Life, I love you, all this groovy. It is, really. That's what you get. And you know what?
Thank you.
It is groovy.
Okay. And to match with that, I'll have to show you for the day. If Alan can poke that. That's my front yard this week. That's the biggest poppy crop we've had in about 15 years since we put the vineyard in. This is, Jessica took this with a fisheye lens a few weeks ago. I've been out there trying to suppress the grass. And I asked her to come by in another week or so, but now the grass is in competition with the poppies. It may not look this good again, but I thought that would be a nice graphic for a change. Okay.
That's what happens when you don't use pre-emergent.
Jeff, you're up for word for the day.
All right, there we go, unmuted. Well, in spite of our current events that we have going on and this unprecedented sign that we're all in, I kind of thought we should probably talk about something that isn't so groovy on this particular day. My thought of the day was going to be about tax day. So I thought instead of talking about like where our taxes would go and creating that whole large debate, I think maybe I'd just do a little civics lesson in the history of how April 15th suddenly became this dreaded day. As we all know that death and taxes are the only things that we can count on. That's what we'll have. Now, before I start anything, I just wanted to add that any quotes or disclaimers that we have doesn't necessarily mean that I support, endorse, and or condemn these individuals. I just thought that they were really good quotes for today. So anyways, our current tax day is because of our 16th Amendment for our current tax model. It was ratified in February 3rd, 1913. And they decided then that the original tax day would be March 1st of 1914. That was basically 1 year post the amendment. It's been changed twice since the 16th Amendment came into fruition. And that was March 15th in 1918, and then April 15th, 1955. And as I delved deeper, it turns out that it was easier for the IRS to process everything, even though that they try to operate on a fiscal year. And it also allowed them to hold the money 1 month longer and get that much more interest from everything that is there. So with that, I did manage to find a nice little poem that I think kind of sums up our responsibility for taxes. And it's that time of year is finally here, that time of year that people fear. Gather up your W-2s. It's time for you know who. Uncle Sam's hand is out and he wants his fair share. You know as well as I, it will not be fair. But people say that that's the price that you pay for a slice of the pie to live here free, and that's the cost to you and me. And that's Taxes by Ray Hansel, who is kind of a current poet living in Gilroy, so I thought it was appropriate that at least we had somebody regional. Now, this very last slide, this kind of carried me through. This has been my mantra almost my entire adult life through both the Navy and then working in the fire service and now, and I think it embodies everything that we are about Rotary, and that it is only necessary for the triumph of evil is for good men to do nothing. And that was from Edmund Burke. He was an Irish statesman who went through a lot of racism way back in the 1700s. And I think it kind of still holds through for today. So everybody, that's my thought for the day.
Thank you.
Thank you, Jeff. That's great. Okay, the infamous meeting front line for our third electronic meeting. Glenn Kubiak is the Zoom master. Today's Spur reporter will be Tim Barry. Audio visual is being done by Alan Frank, and videographing, where appropriate, by Niall Runge. Thank you. Do we have any visiting Rotarians amongst us electronically? Okay, I guess not. Do we have any guests of Rotarians amongst us? Okay, moving on.
Helen Gladden is here.
Oh, well, jump in, Hank. You're supposed to do the introduction.
Helen Gladden is the principal of Livermore High School. Also, the principal of Vineyard High has been invited. That's a lady by the name of Estrada Hidalgo. I don't know that she's actually here now.
She is.
Oh,
Carla's here with us as well.
yes. And then there will be 3 students from Livermore High who are actually the March students of the month, and then 1 student from Vineyard High, and then we'll be coming to that portion of the meeting shortly. Or did you want to do that now?
We're
Jay?
glad you're both here. Thank you so much. Okay. You want to jump back, Alan, to the short announcements I had? Number 2, yesterday we made our $20,000 donation to Stanford Health Valley Care. They were very pleased with that. It's half DDF funds and half club funds. They will be converting some 10 or 12 standard rooms to critical care rooms with negative air pressure The interesting thing that Rick told us is at present the hospital is running well below capacity, which makes them comfortable. They're at about 40% capacity because there's virtually no elective work and people have quit driving cars into things, so the emergency rooms are not full of trauma patients. So it's they're holding their breath, getting ready for what they expect might be a surge. And we were extensively interviewed. They put out a nice press release, so there should be a story in the Independent tomorrow. And then the next one, this is the end of a very long saga. If you could jump to the next view graph. The UC retiree lawsuit. On Monday, in an unprecedented telephone hearing, the court accepted the proposed settlement for the last time. They'd never done a court hearing completely by phone. Even the court reporter was working from home. There were no objections to the settlement for class members, so it'll be filed as soon as possible. This is kind of hard right now because all administrative structures of the court are shut down. So the simple matter of doing a filing is not simple, and then that makes it public and final. There's not yet a schedule for mailing the checks out to the class members. As usual, UC is trying to delay their first $20 million payment for 60 days, but I don't think that'll work. And you can look for a story on this in the Independent tomorrow as well.
Congratulations, Jay.
Thank you. That's finally done. Done. All right. I think, Hank, we're next to you for the students.
Okay. Let's see. From Livermore High, we'll have 3 students. I hope they're online now. I don't know. There's Melissa Castillo, Robert Purcell, and Christopher Santos. So depending upon whether they're online or not, then they can present their passages, or Ms. Gladden can, or I. Or is Ms. Castillo here? No.
Yes, she is actually.
Yeah, I'm here.
Okay. Would you like to introduce yourself and read your passage?
She doesn't have the passage. I have the passage.
Oh, okay. Well, very well. Would you read the passage then?
Well, okay, so Melissa, do you want to say hi so people can see you?
Yeah, hi, my name is Melissa.
Does everybody see her?
Yes.
Okay, very good. All right, let me tell you a little bit about the amazing Melissa. She's a very active, organized, and excellent student. She has a GPA of 4.12, has taken 10 advanced placement courses, and will be heading to either UC Riverside or UC Irvine in the fall with the intention of majoring in biology. She is not one to sit still. She believes in service above self and has served as the co-president of our Interact Club for the past 2 years. For years, she worked for her church to raise funds for an area in Mexico known as Tecate. She's an editor of our school's literary magazine, serves as the secretary of our school's chapter of the National Honor Society, is a member of the Medical Explorers Club, took first place in this year's Regional Migrant Program Speech and Debate Tournament, and recently completed an internship with Kaiser Permanente Radiation Oncology. And still, Melissa somehow finds time to play on our school's lacrosse team. She will be the first person in her family to go to college. Her goal is to attend medical school and become a surgeon. We miss seeing Melissa on our campus every day and wish her all the best as she heads to university. Thank you, Melissa.
Congratulations.
Thank you.
Congratulations, Melissa. Thank you.
Thank you.
Robert Purcell, are you on?
Yes, I am. Can you see me?
For some reason, I'm not seeing you when you talk, but that's okay.
It's on as my name. Sorry, his mom is here, Lorraine Purcell.
Oh, nice to see you. Okay, well, let me tell you about this amazing young man. Robert is an outstanding student and person. He has a GPA of 4.13, an SAT score of 1340, and has taken multiple AP courses. He will be heading to university in the fall. He hasn't quite decided which one yet, but it's nice to have choices, where he plans on majoring in civil engineering. He is regularly on the principal's honor roll. He's an active member of the community. He's a member of the Livermore Area Youth Advisory Commission, which is a joint commission with the City of Livermore, the Livermore Valley Joint Unified School District, and the Livermore Area Recreation and Park District. The commission brings together youth and adults from private and public sectors to address the care, health, welfare, and education of Livermore's youth. Robert is also a member of our school's tabletop club, which gets together to enjoy board and card games. And last year, he received his Professional Association of Diving Instructors certification in scuba, along with several other members of our school's scuba club. He recently earned his first degree black belt. Don't ask me how he finds time for all this. We also miss seeing Robert on campus every day and wish him all the best as he heads to university. Thank you, Robert.
Thank you.
Okay, it's very hard to not see these kids every day. It's been a strange time at high school. Christopher Santos, are you there? I know Chris. I saw Christopher on there. Christopher? Well, I'm going to go ahead and read about him. Christopher Santos is a kind, caring, and optimistic young man and an outstanding student who scored 1330 on the SAT, has taken many AP classes, and has been on the principal's honor roll for 8 trimesters. He will be attending Southern Oregon University in the fall with the intent to major in psychology. Christopher is involved in community service work through the Boy Scouts of America and its National Honor Society, the Order of the Arrow. For this work, he received the Outstanding Service to the Lodge Award. His experiences in the Boy Scouts have taught him many important leadership skills and the value of volunteering. Christopher is a highly skilled musician who is currently the male voice section lead in our chamber choir, and he's also our drumline captain. He has been involved in our drama productions all 4 years of high school. Christopher collects vinyl records, enjoys making music, and loves watching theatrical and musical performances. We miss seeing Christopher on campus every day and wish him all the best as he heads off to university. Thank you, Christopher. I think he's being shy.
Now, Helen, have the students received their plaques so far?
So I'm going to be picking those up today, and I will talk to the students about the best way to get them to them.
Okay. Well,
no, she knows, Hank, she knows that I have the plaques.
Okay.
The students, you can see the plaques here, and these will be, Mrs. Loudon will pick those up from my home and deliver them to you. So congratulations to all of you.
Thank you.
Okay. Then for this month, we have Vineyard High School, and that's Miss Estrada Hidalgo. Is she present now?
Yes, I'm right here. Can you hear me?
Okay. Would you like to introduce the student from your school?
Yes, unfortunately, she was not able to attend this virtual meeting, but I will definitely read about her. Her name is Khalees Bradley. So we would like to nominate Khalees Bradley for the Student of the Month award. Khalees has grown into a very successful young lady who strives to continuously improve in her everyday aspect of her life. She has attended Vineyard since her 8th grade year and has demonstrated resiliency, maturity, and success. This school year, she became Vineyard Alternative School's first ever ASB president and brought a wealth of ideas to the group, which she has helped to execute. Khalees has brought our students together as a community through organized meetings with purposeful agendas and has helped to rally students around fundraising efforts as well as community service projects. Having initiated this association this school year, she has paved the path of excellence for future Vineyard ASB presidents. Khalees has also been a pivotal person in the growth of Vineyard's leadership class. She has supported every member and has respected others' opinions, even when they were not similar to hers. She has helped guide Vineyard's leadership class and is one of the few students who are prepared to provide peer counseling. She consistently came to leadership class as well as her other classes ready to be engaged and wanting to participate in all of the lessons and conversations. While in class, she is a student who is never afraid to ask questions and has worked on assignments with focus and intention. She is a responsible student who would take the initiative to inform teachers when she could not attend class, and then would come on her own time to inquire about missing assignments. Her digital photography teacher mentions, quote, Khalees has always been polite and willing to work and learn new things, even when that meant to affront challenges. She enjoyed working with classmates and was not only responsible, but also trustworthy. It was absolutely a pleasure to have her in my class, end quote. In ASB, leadership, and in all of her classes, as well as around campus, Khalees has become the face of Vineyard Alternative School, welcoming students and encouraging them to participate in our opportunities that we have to offer on campus. She's never shy, and she never shies away from challenges, whether it's in class or dealing with new concepts or new experiences. In class, if she doesn't understand something, she works at it until she does. For example, although challenging, Khalees completed a full year of OLP classes focused on child development and psychology during her junior year, where she served served elementary school children and primary teachers. Additionally, this year she participated in our first annual Poetry Out Loud contest and won second place. Khalees is very respectful, funny, tenacious, wise, and thoughtful young lady, and strikes many as someone who is wise beyond her years. She has a gift for making people feel good about themselves and genuinely cares about them. Khalees is like a ray of sunshine. She is always extremely polite and says good morning and tells us to have a good day before she leaves. Khalees has been a very positive role model for our students and is someone who fully deserves to be honored as Student of the Month. So thank you. I appreciate this opportunity for me to share with you about Khalees. And I did ask Khalees to share some remarks. And she mentioned that after graduation, she plans to attend Las Positas in the fall of 2020. She also looks forward to being part of Las Positas student government, and she hopes to study psychology because she wants to become a child psychologist in the future. She also wants to be able to help adolescents like herself cope with their emotions in a positive and effective way.
Thank you.
Thank you very much. All right. Congratulations to the principals, to the students, and Hank, congratulations to you. An upcoming event, as you know, Eric Swalwell has promised us a video town hall just for the club. This is its third date now, at Tuesday, April 21st, 11:30 a.m. It will be run by his office using a Facebook system that I've not seen before, so information will be coming. But as always in dealing with the Congress, this could be a moving target. So stay tuned for both technological update and date information. Then I guess it's time to go to the program. Kathy, would you? Well, all right. This is in the deck. There we go. Let's do the yeah. Kathy, would you introduce the program?
Yes, I will. I just saw the railroad, so I didn't know whether it was really my turn or not. But I'll go. All right. I don't have a shared screen. You're just going to see me. I actually had attended the meeting with Castro Valley, the first Zoom meeting of a Rotary Club I attended. And this young woman was the speaker talking about how I learned to stop worrying and love social distancing. And it was really, really well done. And I think you'll all enjoy it if you didn't already watch it, because we sent the link out to you in the spur. But this is a young PhD MD student from UCSF. And I know Milt Finger was always really interested in PhD MDs from UCSF because his son was one. But her name is Parnaz Vazuni. And she is probably in her 5th or 6th year, I would think 6 years there. And she says she fell in love with viruses in middle school when she read the book, The Hot Zone. She graduated from UC Berkeley with a double major in molecular and cell biology and political science. She is in the sixth year of her studies for an MD, PhD as part of a highly competitive medical scientists in training program at UCSF. Her PhD research is in the laboratory of Melanie Ott at the Gladstone Institute, which concerns HIV and coronavirus. I have to read her disclaimer. The views in this presentation are those of Ms. Fazzuni and not necessarily reflective of those of the Gladstone Institute or the UCSF. So she was a really interesting young woman. She did a great job in her presentation, and I hope you enjoy it. Take it away.
Great, thank you, Kathy. So I'll be sharing the presentation. I just wanted to warn folks that the first few minutes were clipped. They were unrecorded by Castro Valley. So it starts rather abruptly, but it only misses a minute or so. And it goes about, I'll turn it off before the question and answer period so that we can have our own question and answer period that Brian Mayle has agreed to stay and try to address questions that folks may have. So here we go.
So I'm now a sixth year. So I've done those first 2 years in medical school. It's my fourth year working in Melanie Ott's lab. I've spent these last 4 years mostly studying a different virus, HIV, which is has some similarities to COVID-19 in that there was an outbreak from animals and it's really had worldwide sustained spread in humans. And I have been in particular working on developing better diagnostics for HIV. So for the past 3 months only, I have been working on COVID-19 in the Ott lab at the Gladstone Institutes. And so some disclaimers, I'm not a doctor yet. The information is really rapidly changing every single day. There's new information, there's modifications to what we thought we knew about the virus. And so I will try my best to give you a sense of what the current accepted knowledge is now, subject to change. I view myself as a synthesizer and an interpreter of the facts and opinions from actual experts. There are really few true coronavirus experts in the world, people who really spent their whole lives studying this clade of viruses and people who really know and study pandemics. I am not one of them yet, and I would be skeptical of most people who claim to be or speak too definitively about this outbreak because I really think we don't know enough to speak in such a way. And of course, I do not speak officially on behalf of UCSF or the Gladstone Institutes. So for the past several months, I think we have all been deluged by headlines of varying, predicting varying catastrophes and economic collapse. As of just before this talk, I double checked, there are 407,485 cases worldwide. To give you a sense, that's just under half the population of all of San Francisco. And about 300,000 of those people are still sick. So meaning another 100,000 have either recovered or died. And so what I'm hoping today is to get away from kind of these sensationalistic headlines and get a good understanding of the information and facts that really matter that can inform our response. And so before we take a deep dive into coronaviruses, let's first take a step back. What is a virus really? One of my mentors in the lab when I first joined showed me this 1936 article from the New York Times where viruses were described as a new link bridging the gap between the animate and the inanimate, which offers evidence for the existence of a twilight zone between living and non-living matter inhabited by shadowy creatures. And I think really this is why I have long been fascinated by viruses, both philosophically, intellectually, and scientifically. They're really somewhere in between alive and not alive. And you can see that a tiny, tiny little virus has wreaked havoc like nothing else has managed to do. This is for me, I'm only 27 years old, but for me, this is the most drastic measures I have ever experienced living in the US for my entire life. Others have perhaps experienced things in a war akin to this, but I would say that it's very impressive that such a small particle that may or may not even be alive has wreaked so much havoc. So what is a virus really? In the most simple terms, a virus is simply a sack of proteins and genetic material. Viruses depend really on a host cell for raw materials, energy, and ability to multiply and spread. The first virus was discovered in 1892, the tobacco mosaic virus. where they found that when they took infected tobacco leaves and they took extracts from them and filtered them, which should have retained the bacteria, there was still something infectious there. And so they didn't quite realize what it was. The first time they actually called it a virus was in 1898. But they knew there was some particle that was infectious, and they knew that it was not a bacteria. And so because viruses depend on the host cell and they're not able to replicate alone, they are forced to be parasites. And what's fascinating is that they parasitize all biomolecular aspects of life. Bacteria get infected by viruses. Amoebas get infected by viruses. Protists, all animals, every form of life we have looked at, so far, if we look hard enough, we will find a virus that is able to infect them. So really, viruses are the smartest, inanimate organisms alive. And it's thought evolutionarily that they really date back to the very origin of cellular life. From the time there was first a single cell on the planet, a virus was there as well. And these two, over billions of years, have been evolving together. And what's most interesting about viruses that you may not believe now when you hear about the death rates for COVID is that most viruses are persistent and innocuous, not pathogenic. The goal of the virus is simply to replicate. The goal is not to kill the host. Killing the host is an often unfortunate and often rare byproduct of infection. And as I mentioned, because they date back to the very origin of cellular life, there has long been an evolutionary arms race between the virus and the host, each trying to evade each other, which we call the Red Queen hypothesis, where each organism must constantly adapt, evolve, and proliferate in order to survive while pitted against another ever evolving organism. And then what I find extremely fascinating is that we often have a symbiotic relationship with viruses. And the placenta, actually, which is what differentiates us mammals from egg-laying animals, is that placenta, the protein that was essential for making the placenta, the syncytial cells, that is derived from a viral protein. So the placenta is only 160 million years old. Occasionally, some viruses actually insert themselves into our DNA genome. And it appears that a viral envelope protein was at some point captured during evolution into our genomes and was trained through evolution to operate in human biology and allowed us to form the placenta. So viruses are not all bad, is my point. So how do humans get new viruses? We're constantly inundated by exposure to viruses. And really, for the most part, we don't think of viruses as super harmful. Everyone gets a cold or a sore throat occasionally, and it usually doesn't cause much trouble. Now, viruses are constantly mutating, and so new viruses could emerge just by mutations in the currently circulating viruses. And so unless the changes are major, usually our immune system, through prior exposure and training and this evolutionary arms race, is able to handle it. But sometimes completely new viruses appear that humankind has never seen before. So let's take Ebola as an example. Here you can see that what we call the virus reservoir, or an animal where this virus can replicate but usually doesn't cause disease, in Ebola is thought to be bats. Sometimes the bats might have feces that fall on the ground, or plants or water might be contaminated by the bat's saliva or feces, and a wild animal such as monkeys might eat that fruit that's contaminated and become infected with this virus. Then when often it's thought that the first crossover from Ebola to humans occurred when a bushmeat hunter potentially was butchering a monkey and may have cut his hand, and the virus was previously infecting the monkey and now infected the human. And then sometimes, not always, the virus can actually be able to facilitate human-to-human infection, where we get sustained transmission. Oftentimes we'll get a single human be infected, but they might be the dead end host. The virus is not able to adapt to the human and not able to infect new people. But by pure luck and by increasing interaction with wildlife, we do increase the chance that a virus could potentially get lucky, be able to replicate in the human, and we would get sustained human-to-human transition. Now, I've been hearing a lot of people saying, we should ban these live animal markets in China, and sometimes bordering on kind of racist takes on, why we have this virus. But let's not forget in 2009, the H1N1 swine flu that originated on this side of the world. And we come into contact with livestock all the time. How many of us have gone to or taken our children to petting zoos? An infectious disease doctor would never allow their child to pet animals at a petting zoo because we as animals are closely related. And so that means that a virus that could infect a pig could also have the potential to infect a human. And so the H1N1 swine flu was actually a really interesting virus where there was a human flu virus, an avian flu virus, and then also a swine flu virus. And these three viruses inside one pig that happened to get infected by pure chance with all three, there was some different combinations between the flu that created a brand new strain of influenza that we as a human population had never seen. That through, having pig farms led to pig to human transmission and then sustained transmission in humans leading to the 2009 pandemic. So now we know a little bit about viruses. We know a bit about zoonotic transmission, which is what we call this jump from species to species of viruses. Let's get into what coronaviruses are. So on the left, we have an electron microscopy image of viral particles, and they're named corona, which is Latin for crown or halo, for this kind of crown-like appearance or halo-like appearance around the viral particles. Some of the kind of more important features of the virus to know, if you were to cut the virus in half and look on the inside, it has a genome. So we have a genome made of DNA that we inherit from our parents, one copy each. And the viral genome is actually made of RNA, which is different than our genome. And this RNA, like I said, it's a stack of protein and genomic material. So it's RNA and a protein inside the virus, and it's surrounded by this lipid bilayer and some spike proteins is what they call them. Now, two really important things. So number one, because this virus is encapsulated with this lipid bilayer, that means that soap is actually really effective against this virus. That's why everybody's been begging you to wash your hands. Soap is able to disrupt this lipid bilayer and disrupt the virion so that it's no longer able to infect you. And so by washing your hands well, you're destroying the virus and you're prying the virus apart. The other thing that's really important to know about is the spike glycoprotein. This is what the virus actually uses to attach to the human cells and infect us. We know a lot about this spike glycoprotein because the spike glycoprotein in SARS back in the early 2000s was very similar. And so very quickly, as soon as we had the genome for this novel virus, we were able to figure out by genetic analysis how similar the two viruses were and make a prediction that it would be very likely that this SARS-2 or COVID-19 can infect the same cells as the original SARS. And this is called the ACE2 receptor. And so this is expressed on lung cells. So this is why you get respiratory infection. It's expressed on gut cells, which is why sometimes diarrhea is reported as a symptom, although rare. And I'll get into the clinical manifestations. But the other things that I'll say is that so far we've discovered 7 human coronaviruses. 4 cause the common cold. We have probably all been infected with them. And then the other 3 is that SARS in the early 2000s, MERS or Middle East Respiratory Syndrome, and now SARS-CoV-2. The first coronavirus, we've known about these viruses since 1937. And we know that they can infect cattle, pigs, cats, ferrets, turkeys, mice, dogs, rats. And so really, these are ubiquitous in our environment. And so we should expect that this is not the last coronavirus that we will be exposed to. So where did COVID-19 in particular come from? So COVID-19 is the disease name. It stands for coronavirus 2019. So this is the disease. It's caused by the virus called SARS-CoV-2. So this is the disease, this is the virus name. Just before the new year, China reported this cluster of pneumonia of unknown etiology. And the first cluster of patients emerged in Wuhan, Hubei province in China. And it seemed to be associated with people who either frequented or worked at a seafood or live animal market. However, I will say that there's still been some debate as to whether the virus actually originated from that market or somebody got infected who worked there elsewhere and then came to the market and spread it there. It's now been declared a pandemic. What is a pandemic? A pandemic is a global outbreak of disease. And by early on in China, the first few patients, they sequenced the genome of the virus. This allows us to compare it to all known sequences in the world. And we found that there's great sequence similarity to some bat viruses, that people had gone out, they had gathered fluids from different bats and sequenced the different viruses that were in there. Like I mentioned, Ebola is also thought to reside in bats. And so bats really contain lots and lots of different viruses that don't make them sick, but could make us sick. And so it's thought that bats are likely the original reservoir, but that there may have been an intermediate host. Some have suggested the Malayan pangolin, which is this kind of interesting, scaly, sloth-looking creature. You can see here that they sometimes illegally use in many parts of the world. And then there was some type of final zoonotic transfer to humans, is what kind of these genomic investigators have figured out so far. And then what I will say is that we haven't found an animal coronavirus yet that is exactly close enough similar to this virus where we can say that it is the direct progenitor of this virus. And that's really because the diversity of coronaviruses and viruses in general in bats and in other species is massively undersampled. So what we really need to be doing is hunting for these viruses actively in animals and at interfaces between humans and wildlife to get an idea of what the next pandemic could be. And I'll reiterate this later in the talk. And so the idea is that if this virus is pre-adapted in another animal species, there could be future reemergence events. You may see that Ebola every few years, it seems to disappear and then it reemerges in the human population. So what is the clinical manifestation of disease? And you know, there's a lot that's changing about this virus, but I will just give you guys some clinical pearls that I have heard about both at UCSF and University of Washington, where the first cases in the US were sequenced by actually a graduate of the MD-PhD program at UCSF who I overlapped with. And so the common triad is a fever, not necessarily high, sometimes it can be low, cough, and shortness of breath. And so fever is seen in about over 75% of hospitalized cases at some point, but almost 50% are afebrile upon admission. Cough, we see in about 60 to 80% of patients. Shortness of breath is in 20 to 50% of patients. So you can see none of these are really the definitive factor for diagnosing someone with coronavirus just based off clinical symptoms. And so a lot of times they had been relying on prior travel history, but now there has been so much sustained transmission and asymptomatic transmission in the US that it's hard to really just use travel history as a good indicator for the odds that they might have coronavirus or not. Other symptoms, many people report myalgias, which are body or muscle aches. Between 10 to 50% will report that. There are upper respiratory symptoms such as headaches, sore throat, runny nose, but they're not as common. They're seen about less than 15% of hospitalized patients. And then there are, like I said, there's receptor for the virus is expressed on gut or gastrointestinal cells. And so we do sometimes see gastrointestinal symptoms, diarrhea in less than 25%, nausea and vomiting in less than 10% of hospitalized patients. And you know, the most concerning aspect of this is that there's often a progression to pneumonia. So here you can see on the left, these are CT scans. On the right are chest x-rays. So this chest x-ray here, this is would be a non-severe case where you can see the black area is really outlining the lungs. The lungs should be filled with air, so it should mostly look black on an x-ray. Here in the severe case, you can see that because the lungs are filled with fluid and virus and pus and dead cells, which is what pneumonia is, they turn this kind of opaque white color. And so this would be a very severe case of pneumonia. And the classic pathognomonic finding on the CT scan is what we call ground glass opacities, where taking basically cross sections of the lung, this is the heart here, these are the two lung fields, they should look black and relatively clear, but you can see that they're occluded and they kind of look like if you had cut up glass and sprinkled it in there. And so really the virus is very smart. As the virus infects a lung cell, It will start multiplying in the cell. The virus will want to burst out and infect neighboring cells. And so it'll crawl progressively down your lungs and infect different cells in your lungs. And then when your mucous membranes become inflamed, when your lung sacs or alveoli become inflamed, you start to have trouble carrying out the function of supplying oxygen to the blood that circulates through the lungs. And so that's why you get this shortness of breath, because your lungs have filled with this pus, this fluid, these dead cells. You start to have difficulty getting good transfer of oxygen from your breath to the actual lung cells and into the blood. And so this is why a lot of people end up needing to go on a ventilator. This is why even young people sometimes need to get supplemental oxygen in the emergency room or in the hospital. So who is especially susceptible? Well, as it turns out, age is a major factor, age 65 or older. In the US, 8 out of 10 of the deaths have been in adults above the age of 65. Up to 27% of adults above the age of 85 or older have died. That's pretty bad, is what I would say, compared to most other viruses. And among the age group 65 to 84, between 4 to 11% of infected adults have died. Comorbidities, so things that can make you have a more severe course of disease, include diabetes, any chronic lung disease, cardiovascular disease. In China, the odds of progression to severe disease was 14 times higher in smokers. So if you've ever been looking for an excuse to quit smoking, I would say now is the time. And then those who are immunocompromised. So people who get cancer treatment, they're an organ transplant recipient. Some people have autoimmune diseases where they need to calm down their immune system and take different drugs. Those people are especially immunocompromised, even if they are not above the age of 65, and especially if they're above the age of 65. And then nursing homes, they tend to be bad sites of outbreaks in general, but because there are often comorbidities, because the age is high in nursing homes, that's really just, if coronavirus ends up in a nursing home, that's someplace that we're going to be really concerned about, and there's going to be a high level of morbidity and mortality. And on the right, you can see a graphic created by BBC, where this is based off of the Chinese data, but you can see it mirrors kind of the preliminary data that we have out of the US, where the age, really, if you're above the age of 65, you're at quite high risk of death. These health conditions really increase your chances of death. And there doesn't seem to be too much of a predisposition for male or female. It's thought that in China, maybe more of the males were smokers. And so potentially they might see an increase in deaths in males. So why is this virus so particularly bad? Well, there's a few reasons. Like I said, the virus is new. It's novel coronavirus is what it was originally named before we came up with the name COVID-19. And so our immune system has never really seen this. And so unless you have been previously infected with SARS, which even then we are unsure about, it seems that our immune system, this is really new to our immune system. And so we don't have this evolutionary history of seeing this coronavirus to be able to mount a good immune response to it. In this chart that is from the New York Times, that there have been many versions of it, they're graphing on the y-axis the fatality scale on a log scale. So it goes from 100% to 0. And then on the x-axis, you have the average number of people infected by each sick person, which is called the R0. And so I will go into more depth about that on the next slide. But here in the red square, you can see we have about an estimate of what this new coronavirus has. Most estimates seem to be putting the fatality rate below 3%, although in Italy, it's been much higher due to their higher elderly population or at-risk population, and the number of transmissions from each sick person between 2 and 4. So you can see, if we were to compare this severity to other known viruses, the common cold, the 2009 flu that I spoke about before, those are much less fatal and much less transmissible than this new virus, potentially. In fact, this is less fatal and less transmissible, potentially, than even polio. MERS is extremely fatal. Nearly 30% of people infected with MERS die. But with MERS, you generally have to come into contact with a camel, and human-to-human transmission has not been as much of an issue and as widespread as we've seen with this new coronavirus. Ebola tends to kill most of the people it infects, but because it's so quick and so hot, you don't get to transmit it to as many people. But The other thing that is really interesting about this virus is that there seems to be asymptomatic spread. It could take between 2 to 14 days where you're infected with the virus. You could infect new people, but you have no symptoms and you have no idea you're infected. And potentially even, you may never develop symptoms. You may clear the virus, but you may have infected several people. Now, I mentioned that number R naught before, just to give you an idea again of other viruses. So R naught estimates really how many other people one sick person is likely to infect. So for the new coronavirus, it looks like 2 to 3 people, although again, this is preliminary. Zika, between 3 and 6. Measles is very infectious, but not that deadly. Ebola, you're so sick so quickly, you don't even get a chance to infect other people. And you can see the seasonal flu, you're likely to only spread it to one person. Now, again, why is this virus so bad? So I've mentioned that it's completely novel, so our immune system doesn't really know how to handle it. There's asymptomatic spread, but I think that this chart really makes us understand why testing is so important to getting ahead of this. So here in the red charts, they have the cases in Korea. In the green, they have the cases in Italy. In Korea, they really immediately took charge at the start of this pandemic and started testing people. They had drive-through testing. They were testing more people in a single day than the United States was able to test total as a country over a month. I mean, their testing capacity was really admirable and remarkable. And so because they did such widespread testing, they weren't limiting the tests to just very sick people like we see here, where we don't have enough tests. There, they were able to test everybody. And so what you saw in terms of the age distribution is that when you compared it to the actual age distribution of the total population, it really followed it. And not only that, but you see in the age 20 to 29, nearly 30% of cases were in that age group. But likely most of those people were asymptomatic. However, in Italy, number one, they have a very large elderly population, much higher than Korea, which has a much younger population. And so you really see most of the cases are in, above the age of 50 here. I would say nearly 80% of the cases are above the age of 50. There's been a lot of fatality because this age group is particularly susceptible to death. And then on top of that, they don't have testing to test everybody. They don't have enough tests to test those people who are young and asymptomatic so that we could potentially isolate them and prevent them from testing other people. They were forced to go on a nationwide shutdown. Here, we also don't have enough tests to test everybody. I have not been tested. Most people I know who are my age have not been tested. Even those who are symptomatic are often not able to access tests unless they need to be hospitalized. And so we really don't know. And because, New York, many states have been resistant or even threatening to lift their lockdown orders, these asymptomatic people will go back out and they will continue to infect people. And then the other thing that I would mention is that, although young people tend not to die, when we do get infected and when we do get symptomatic, we still take up hospital beds. And so the other issue in the United States is that we don't have enough beds, we don't have enough ventilators, and we don't have enough protective equipment. And so if young people, even if they're not going to die, but do need supportive oxygen, they may need the help of a ventilator briefly, or they may need to be hospitalized to monitor their pneumonia. They're taking up beds that should otherwise be used by really sick elderly people. And so in the United States, really the problem has been compounded over and over again. Instead of being managed the way South Korea did, by early and rapid testing of lots and lots of people so that we can identify the infected and isolate them and let everybody else continue on with their lives. So I've said this basically so far, but the US response has been, in a single word, abysmal. And so in part, it was the testing failures and mismanagement. So originally the CDC, the Centers for Disease Control, decided to create a test themselves. As it turns out, their test is not very good. I have tried it myself in the lab. I found it to be neither sensitive nor specific. And I've moved on to testing kits from other countries. Not only that, but initially they didn't even realize how bad the test was because they had manufacturing issues where their controls were not good controls. So it took a long time. And because they had centralized it to just the CDC giving out the tests and running the tests, Essentially, other labs were limited from running their own tests until a lab at the University of Washington basically went rogue. They couldn't get access to the test, and they just started sequencing the entire genomes of patients. And that's how they discovered that they had an outbreak in Washington State. And now they are becoming much more, accepting of allowing each place to develop their own tests. Now UCSF has created their own tests. Stanford has created their own tests. But you can imagine if we had a both competent and organized national response, every hospital and university wouldn't have to de novo create their own tests. We could have one that was both effective, unlike the CDC one, and widely manufactured and distributed so that we could get our testing capacity up. The second issue is the lack of ICU beds, ventilators, protective equipment. Doctors are basically not going to have masks or gloves to protect themselves from patients, partially because despite the fact that China really, I would say, bought us time to get these things ready, nobody responded to the call. Nobody saw the warning signs. And so we didn't start increasing our manufacturing. We didn't start stockpiling these things. And so in San Francisco, at least, the UCSF medical students who some of their medical rotations have been canceled in light of this, they have been standing on a street corner and collecting from ordinary citizens any gloves, any masks, any equipment or protective equipment that they have that they could give to the doctors, because within 2 weeks we're going to be out. And it doesn't look like we're getting much more anytime soon. Although I did see today that potentially Donald Trump has authorized the government to take their war powers and to start producing masks, which we also need them to start producing the ventilators. So really, the United States failures have been on many levels and have continued to compound each other. So let's take a look at how bad it really is and where we could have been. So let's take China, for example. These curves, the way to interpret them is that on the x-axis is the number of days since the 10th death, and on the y-axis here is the number of deaths. China, pretty early on, they have faced a lot of deaths, but you can see that they're not really getting new deaths at this point. Within a month, they were able to start containing it, and actually for the last several days, they have reported no new cases and no new deaths. South Korea instituted an early and large-scale testing, and they really took their public health departments and they started tracing the contacts of every known infected person so that they could tell them to isolate. They really put their public health departments to use and to work. And so they got the outbreak under control very quickly. In these dotted lines, these are telling you how the rate of the deaths. So here in this, if a curve follows this line, the deaths are doubling every day. If the curve follows this line, the deaths are doubling every 2 days. Here it's every week. And you can see South Korea, out of all the countries, because of these interventions, and keep in mind they're a democracy, so it doesn't require an authoritarian government to really stop a virus. But they really have, I think, are the model for how to handle a pandemic. On the other hand, we have the United States, which is, I think, is right here. You can see that our curve is still going straight up and doesn't seem to be flattening anytime soon. Spain and Italy have really had very scary, I would say, outbreaks there. In Italy, because they have such a large elderly population, the death rate has been just astounding. They haven't even had as many cases as China, but they already have twice as many deaths as China. And Spain also, it looks to be pretty uncontrolled growth right now in terms of the death rate. And you can see the stars about when the countries decide to lock down. In the United States, unlike the UK, France, Spain, Italy, has not had a nationwide shutdown. It started with, our counties here in the Bay, now California, and a few other states. Now, let's take a closer look. So one of the places that concerns me the most is actually New York State. You can see they are basically going straight up. And if they follow this current curve, their deaths are going to be doubling every single day. And New York currently has the most cases and the most deaths of any place in the United States, despite the fact that the virus first arrived in the US and Washington. California has been doing quite well, I would say. And I think this is in part due to our social distancing. But like I said, it takes 2 to 14 days for those people who are potentially infected to show symptoms. So I would say it would take another week or two before we really know if this lockdown has had an effect. But I would say that in California, it's promising, and it looks like we're starting to get things under control, unlike New York. Madrid has been very hard hit, and Lombardia in Italy has really been devastated by this. So is there a vaccine? Is there a treatment? So vaccines, people really mobilized on the research side as soon as they found out about this virus. And so there are several underway actually in vaccines and trials. But the problem with vaccines is, it takes a long time to validate it. And it takes a long time to get, enough vaccines where we can actually vaccinate everybody. So, we have lots of vaccines underway, but it'll take about 12 to 18 months, assuming all goes well and the vaccines are actually effective. So in that year to year and a half, what can we do in the intermediary? Well, as it turns out that we can often repurpose old drugs to new purposes. And this has been done many times in the medical field. So to give you kind of a brief overview of the drugs that people are using at UCSF, at other institutions, or the World Health Organization announced kind of the biggest randomized controlled trial of several of these drugs the other day. So the first one is called remdesivir, and it's produced by Gilead. I really admire Gilead as an HIV researcher. They, a lot of companies will not produce drugs that will treat infectious diseases because it's thought that infectious diseases only affect the poor. And so they're not profitable the way a statin drug for your heart might be, or a cholesterol drug might be. And so Gilead has really been a leader in infectious diseases. They have a great hepatitis C treatment. They have a drug for HIV. And they created this drug originally for Ebola. And in the lab, some coronavirus researchers many years ago showed that it could potentially be effective against SARS or MERS. And so this, I think, is a really promising drug. It still remains to be seen if it'll be effective against this particular coronavirus and if it will actually be efficacious in patients and reducing the mortality. But there are studies underway all over the world and at UCSF. Other drugs that you may have heard about in the news recently is chloroquine and hydroxychloroquine. They were originally developed for malaria prophylaxis, and also they're used for treatment of autoimmune diseases such as lupus. Our president, Donald Trump, recently announced it as the cure, which there's one preliminary study that was very poorly controlled, is my opinion, that does not definitively show if it has any positive or negative effects. And in fact, these drugs are quite toxic. And so, somebody heard Trump say that this is the cure, this is how you prevent coronavirus. Yesterday, he and his wife took a derivative of chloroquine that's used in aquariums. Actually, he and his wife took a bunch. He unfortunately passed away, and his wife is now in the ICU. So again, facts, information, these things matter. Touting things as cures when we don't have any evidence and we don't have any control is extremely dangerous and costs people lives. So the other drugs that we're looking at is ritonavir and lopinavir, which are drugs that are originally used for HIV and target that viral protease. But because there are similarities between viruses, you could potentially use it against this coronavirus. And then it's also thought, I mentioned that pneumonia is really an inflammation of the lungs where you have fluid filling there. You have dead cells, debris from these viruses bursting these cells open. And so potentially some of the death is because there's so much immune activation that you go into acute respiratory distress. And so if we could calm down the immune response potentially without targeting the virus, perhaps patients would recover better. And so IL-6 is a cytokine or a molecule that our cells release to stimulate an immune response. But if we can block this, and this has previously been used for autoimmune diseases such as rheumatoid arthritis, maybe we could reduce immune activation and inflammation so that the body doesn't get overactivated. So these are things that people are actively trying in the clinic. And I hope very soon we'll have some good controlled data to tell us, are these efficacious or not? What are researchers doing about it? So I'll just briefly, before I end, go through kind of two big things that us at the Gladstone Institutes have been working on and at UCSF. So the first thing, you may have seen a couple articles in the New York Times this last week. So this is from the QBI Coronavirus Research Group. And basically what they do is they take each individual protein that the virus takes. So the viral proteins are in the center here, E protein, M protein, N protein, non-structural protein 1. And they are able to study what human proteins these viral proteins interact with. Like I said, viruses are parasites. They require our host human proteins to replicate and to operate inside the cell. So we know from lots of our other research that viruses interact intimately with the human proteins. And so if we could identify what human proteins are essential or necessary for the virus to replicate, and we already have drugs against those human proteins, we don't need to create from scratch a new drug against coronavirus. We can just briefly block that human protein with a drug, and then we could prevent the virus from replicating and causing disease. So one thing that's really interesting to me, because our lab has studied it in the context of HIV, is this protein called BRD2, and it's close relative BRD4 that interacts with the viral envelope. We actually already have drugs in it. That's also an important driver in cancer. And so we have several drugs that have been used in human trials to block this protein. And so this study was just published yesterday online for all international researchers to be able to look at this data and start testing drugs. And so we're really trying to make our data open and really trying to collaborate as much as we can across the globe to as quickly figure out what drugs might be effective in the clinic, what new drugs in addition to the one that I mentioned before. So this is just a taste of, this is really led by Nevin Krogan's lab at UCSF and the Gladstone Institutes. And I think there were like 10, 15 groups overall involved in this Herculean effort of getting this done in a month, where this would usually take, years. My own research, I mentioned that I've been working for a while with HIV diagnostics. The nice thing about the diagnostic system that I've been working on, which the goal is to have it as a self-test or something you could use at home to detect HIV, originally in my case, is that it's easily adaptable to new viruses. So when we realized what a testing shortage there was, what a long testing turnaround there was, sometimes it can take a week for you to get your results. We decided that we should really adapt this kind of mobile phone-based testing that could be done either in a clinic, at a border, an airport, or potentially even your own home to the coronavirus. So I've been working for the last couple months trying to adapt this. The idea would be that usually it's diagnosed by a nasal swab. This thing goes pretty far back in your nose, I will say, but it's totally doable to swab yourself or have someone swab you. I've done it. And you would take some nose tissue that's near the back of your nose. And if there's any cells that are infected with the coronavirus, you would also isolate those viruses. You would stick this swab into a device. We would cut open the viruses so that we just have that RNA genome. And we have this new technology called CRISPR-Cas13 that is able to really detect very specific pieces of RNA. So we programmed these for the coronavirus. And if they find any coronavirus RNA, which is the genome of the virus, they will also cut a reporter that will fluoresce that you could use your own iPhone to hook onto this device and detect if there's fluorescence or not. So within about 30 minutes, you could have pretty accurate quantitation of whether you're positive or negative for this coronavirus. So finally, what should you be doing about the coronavirus? So social distancing, learn to love it and flatten the curve. The idea of the curve that you have probably seen many times is that without protective measures, we will get a massive rise in cases that will overwhelm our healthcare system capacity. We don't have enough masks, we don't have enough beds, we don't have enough ventilators. If we all get sick at once, people are gonna die just because we have no place to put them. On top of that, we will infect the healthcare workers who will no longer be able to take care of us. And then people who are not infected but have, continue to have heart attacks, strokes, other things that send them to the hospital, they will also die for no reason. However, if we practice social distancing, if we go on lockdown, if we socially isolate, because we don't have enough tests to go around right now, we can flatten the curve, meaning it would take longer for people to get infected. It would be slower though. So, maybe there would be 50 cases here, maybe 100 at the peak, but we would never overwhelm the healthcare system capacity, which would reduce our death rate because we can actually take care of everybody. Like I said, please wash your hands. Soap is extremely effective. Now you know the scientific reason why, so there's no excuses. Use common sense measures. When you do go out to the grocery store, really keep your distance from other people. Stand on those lines 6 feet away from the person in front of you in the checkout line. And then if you have any personal protective equipment at home that you don't need, such as masks or gloves, please donate them to your local hospital because they are in desperate need. And they are the ones who will be coming into contact with the virus, and you at home hopefully will not. And so, what about the future of humanity? I did say, if we could cure this or we could get rid of it from humans, but if we keep coming into contact with wildlife, we could potentially get re-exposed to this exact same virus or other viruses, right? And, actually people have been predicting this for a long time. Someone who I would consider a true coronavirus expert, Bob Barrick, who's at the University of North Carolina, in both 2015 and 2016, warned in prominent papers in scientific journals that there is a SARS-like cluster of circulating bat coronaviruses that show a high potential for human emergence. And so if we continue to do basic science research where we're really going out into the field, we're collecting samples, and we're understanding what is the viral diversity out there, because again, we had never seen this virus before until it showed up in a human. We could start to get an idea of what things should we preemptively start making vaccines for, what should we be studying in the lab, so that the next pandemic we're not caught, flat-footed. And, I would say that there's no escaping viruses. Viruses can be our friends. They can be our symbiotic relationships with us. And, even if we go to Mars and set up a new colony there once we've destroyed the Earth, there are viruses on your skin. There are viruses in your gut, in your throat, in your nose that we will take with us. And so there is no escaping them. But through climate change and globalization, climate change by changing the habitats of wildlife that will force them to come into contact or restrict their habitats, globalization where we encroach into animal habitats, those will all lead to more interactions with wildlife that potentially harbor novel infectious diseases that we have no predetermined immune response to. So really, this should not let us forget how important it is to mitigate climate change and how important it is to be mindful of our globalization efforts. And, the more we fly, the more we travel across the globe, the greater the risk is that we could spread these new viruses, which is exactly what happened here and what always the fear is with Ebola, that somebody might bring it to the US and there would be local spread here. Again, please lobby your congressman, your senator to fund basic science and biomedical research in infectious diseases in public health departments. Public health is frequently underfunded. Infectious diseases doctors actually take a pay cut from just being a regular internal medicine doctor to get 2 years of a specialized additional training. Like I said, people think that infectious diseases only affect the poor, and so we don't see a financial benefit into pouring money into it. So we really need to lobby our government to take infectious diseases seriously, because you can see what a tiny little virus has done to the global economy. And then finally, international cooperation, heeding warnings is key to future pandemics. I would say that China really bought us time and really did the world a service. We did not heed their warnings. We did not take that month that they gave us an advance warning to get things together in the United States. We were ready for the response. And this is really why, if we had widespread testing, we would not be all in social isolation and lockdown. This is really a failure of government and a failure of competence. So with that, you may have or may have not gotten my initial reference to my favorite movie, Dr. Strangelove, or How I Learned to Stop Worrying and Love the Bomb. But thank you very much for your attention, and I'm happy to take any questions.
Okay, we'll stop the video there, and I will stop sharing so that we can have a discussion. And as I mentioned earlier, Brian Mayall, if he's still on, has agreed to address questions if anybody has them, and any other discussion.
Glenn, can I just interject here for a second? I wanted to remind people that this presentation was done March 23rd.
Yeah.
So I appreciate there's a lot of changes since March 23rd, but she was pretty good. So that's all I wanted to remind people of.
And Kathy, thank you so much for bringing that to our attention. Questions for Brian?
So I have a question for Brian. Brian, what is your opinion on the mixed stories or theories that coronavirus in the Bay Area possibly as early as the fall?
See, I am having to unmute you, Brian. Just a second. You can do it. There we go. Okay, say again, Carolyn.
So I just wanted Brian's opinion on the stories or the theories, and there's kind of some some mixed theories about whether coronavirus was actually in California in the fall.
I think there was no, well, there are two ways of answering that. One of the thing, Carolyn, that we really don't know who has had it or where it was. There's no indication that anyone was being hospitalized or anything for the coronavirus, but there could have been asymptomatic ones wandering around before. And this is the whole point of testing. It's just to get a feel as to what the distribution of the virus is in the population and who are the people carrying it and who are the contacts of those people. And then by doing massive testing as they did in Korea, you can sort of isolate the little clusters and the rest of the population can go about their business.
I have a question.
Mm-hmm.
Most of the models we see have a decay curve that is similar to the rise of the infection. Is there any reason to believe that that is true or that it will follow a different curve?
It's probably true, Alan. It looks as though it's following what is called a logistics curve. Sooner or later, a critical number of people have been infected and there's nowhere else for the virus to go, and so it decays out. One of the things that really bothers me, you realize that this flattening of the curve is just the postponement, and all the indications are that somewhere around 50% of the population, that's us, sooner or later we'll get it. And that time is just being delayed at the moment. And so that's a little scary. I don't know about you in the sense I would have preferred to have got it over with or be 6 feet under, whatever happens, but do it. But in the meantime, we'll have to live with this uncertainty. The only glimmer of hope is that we can do it long enough that there will be some sort of a vaccine available for us.
Question. Brian, I heard a doctor, a professor at the University of Maryland, talk about some work done in Russia using polio vaccine. And he sounded cautious but optimistic and is pushing for polio vaccine testing to be done for coronavirus. He referred to it as a interim inhibitor. Any thoughts?
That's the old thing, hey, if you can't treat it directly, try and treat it indirectly. And it's like all of these things, we can have all sorts of nice ideas and things are happening. Yes, in 2021 or 2022, there may be a vaccine available. My betting is that it will be about as effective as the flu vaccine, which means it's about 50% effective, but it's enough to damp down the epidemics. And,
Bob Cowan, I have a question.
Yeah.
I read somewhere that the severity of cases may be related to how big your initial dose of the virus, you're exposed to. Have you heard anything about that?
Yeah, and that's a real possibility. If you get a big dose, you tend to have a more rapid and stormy course. But on the other hand, the clinical behavior of this thing is really weird because it seems to cause this long, lingering illness, for a week or so.
And then some patients get rapidly worse after that period of time, either developing the pneumonia, as she said, or else even more scary is what they call CSS, which is a cytokine storm. It's like anaphylactic reaction, and it's an immunologic reaction. And that is what seems to kill most of the younger people that die from it. It's never been seen before that a viral infection and so on can precipitate this cytokine storm. It's seen in patients that are getting infusions and so on occasionally. It's really scary. And I have a little slide here. I don't know if it's showing up for everyone or not.
Yes, it is.
Okay. Can I take just a moment and quickly go through it? I think you may find it a little interesting because I just compared polio with flu with SARS. And polio is an extremely small virus, whereas the co-virus is a little bit bigger. Thing that polio in green is, of course, there's no animal reservoir, unlike the SARS and flu where bats seem to be. Polio is also very stable. Flu mutates at a very high rate, and SARS looks as though it's mutating at a moderate rate. All three of them are highly contagious. And as they transmitted, polio, of course, we know is fecal. Cough is an underestimate. Speaking, shouting, sneezing, anything exhaling is a way of transmitting it. But both flu and the SARS seem to be highly infective. Flu, everyone knows very quickly if you've got flu. Polio, most people never know they've had it at all. And the SARS-2 seems to be intermediate in that. Lethality, you saw the slide she showed on that. But the difference is you can also get disability with the SARS. It seems as if people who've had SARS often don't fully recover for whatever reason. Really scary thing is that the SARS hits all ages, and particularly young, healthy adults. And it's the first time we've had an epidemic like this that basically is targeting the working force as well as the aged. We don't, even though the death rates are about the same, we don't care so much about the flu. Hey, that's us old folks. If we don't go with that, we go with something else. But the fact that the SARS is lethal or highly debilitating for younger people is something that really sets it aside. Okay, I'm a skeptic. I don't think any of these, the viral infection itself is being treated, and I'm not holding my breath. It took a long, long time before the only really efficient viral treatment, which was for HIV, was developed. And a reminder, with polio vaccine, we have excellent protection. Flu, so-so, and my betting is SARS will be behaving very much like flu, that the vaccine will maybe modulate it a little bit and modulate its spread, but it's not going to afford anything like the protection that the polio vaccine did. Anyway, that's a little lecture. I'm sorry I've gone on too long.
No, thank you very much, Brian. I guess just it's a wonderful program, wonderful commentary. Brian, you certainly added a lot. And next week, we look forward to a ride on the railroad with Alan Frank. So well past 1:30, we stand adjourned.
Great meeting.
Thank you again, Glenn.
Thanks, everybody.
Yes.
Good job.
Thank you.
Thanks,
Thanks,
Brian.
Alan.
Thanks, Kathy.
Simon,
Program.
I'm just going to hang around a little bit if there's anyone else wants to converse.
Okay, I'll keep the meeting open then. I was just about to end it, but that's a good point, Brian. I will keep it open.
I have a question for you, Brian.
Okay, Kathy.
I know that when you did your polio talk, you said that a lot of people who have polio are asymptomatic. They're shedding the virus, but they have no symptoms. And that's what we're seeing with coronavirus. So I think that's, for me, what makes me most nervous is that we're not doing testing to know who actually is a carrier, even if they're not sick, and are they a carrier? So what's your opinion of that?
Okay, well, first of all, there are two types of testing, and we need to be very clear. One is testing for the presence of the virus, and the other is serologic testing showing that you have been exposed to the virus and recovered. And so I think you're talking about the first, Kathy, which is detecting the virus. And this, I think, is, well, I thought she did a very good job of skewering the administration on that, or the whole attitude of the Western countries, I think, that just were not prepared to gear up and mobilize the resources that were needed to do testing. And think of the logistics.
Yeah.
Great excitement. We're doing 100,000 tests a week. Hey.
Did Brian, when you get a
1
chance,
million,
I had a thought.
5 million.
So we will be social distancing for quite a while.
Yes, I think, like the governor says, we'll be able to start modulating it a bit. All wearing masks out in public, not to protect ourselves, but to protect everyone else, because we may be a silent carrier. But mass gatherings and so on, I think, are out. And the curve is getting flattened, but it can then be a very, very long plateau before it starts really going down. And what we have done, at least, is got an adequate number of hospital beds here, unlike New York, which is a tragic example of what could have gone wrong nationally.
So Brian, I have a question when you get a chance. I didn't mean to speak out of turn. The question I have is whether you have a perspective on the tools that are emerging before we have testing. Like, there's two surveys that I take either daily. One's from Stanford. Basically, first is a long one, the first time you take it, that asks you a bunch of questions, including about your ethnic background. But then the follow-on ones are just, are you feeling well? Are you having any symptoms? Have you been with anybody who has symptoms? And so it's just a few questions. And then as I understand it, the Stanford people are using those survey results to essentially produce hotspot maps. If you start seeing a bunch of fevers popping up, you can use that information. Do you have a perspective on that? And then the second question is really, do you see the same capacity that Rotary built to deliver polio vaccinations as a way to get a physical thing to people, whether it's tests or testing equipment, or whether it's, some of us are talking, actually it's premature to talk to the whole club about this, but we have an initiative where the KINSA digital thermometers are being provided to our school district. 1,000 of them are on their way to our school district to use in this capacity. And these digital thermometers are getting a lot of play, KINSA's in particular, about being used with big data to strip out, if you will, the seasonal flu fevers and then use them as indicators for emerging COVID-19 data, again, kind of to map it. So I just wonder if you have a perspective on those two topics.
Well, the thermometers as a surrogate, I think, is a very good idea. It's a stopgap, but it's a reasonable surrogate. Actually, you gave me three things. And,
well, the first one was
the Stanford thing, again, I participate in it, and I think it's a very reasonable thing. It's a pity that because of all the privacy concerns and so on, we can only do it on a small subset of the population who agreed to participate. There's the HIPAA, which is the Protection of Patient Information Act, has absolutely tied the hands of our hospitals and so on, trying to get information, so that you can only get information indirectly about who's getting it or not getting it, and so on. It's very, very difficult for the epidemiologists to keep current.
And I guess the third question was whether or not our capabilities, more in the developing countries where people like Beth have gone on polio days to vaccinate, whether that capability for us to get that last mile to the individuals who might be in under-resourced communities could be exploited in this case, either to deliver testing equipment, if there was an abundance of it, or to deliver digital thermometers, for example. I just wondered, because KINSA is working in India, for example.
Well, I'm a pessimist on this. I think it's like trying to get rid of the flu thing, or do anything about it. Interestingly, of course, there's been a dramatic drop in the flu season following the shelter in place. So
yeah.
It's an anticipated benefit.
We have a question about, I'm not too proud right now to be from South Dakota, so could you comment on the governors of South Dakota's?
I'm not going to get drawn into that one.
But Lynn, you're referring to the hotspot at the food processing or the processing plant?
Governor Christie is refusing to do a shelter in place.
Yeah, what was it? Springfield processing plant up there. Got it. In retrospect, all planes should have been grounded right at the beginning, the same as we did it for 9/11. The traveling around the country is individuals moving from one place to another place, and it's going to keep on going, and the virus is going to keep on spreading, and doesn't recognize any boundaries or anything else. There's populations that tend to live close together and indulge in a lot of intergroup interactions, are the ones that are going to get hit worst. More isolated communities may escape. I don't know.
How much do we know about the Spanish flu and how it compared to this?
Alan, there's an interesting article that really caught my attention on that, because they think the deaths from the Spanish flu were largely CSS. That the Spanish flu precipitated the cytokine storm syndrome and with that. I think this has only just very recently been recognized that that was probably what was going on. And it's this ability to precipitate the storm, which makes it so terrifying, because the people that get hit with the cytokine storms are the young, healthy people. The old and the infirm don't get cytokine storms because our immune system is sort of tempered down a little bit as we get older.
So I hate to be a party pooper, but it's after 2 o'clock now, and the host, I have to move on to another commitment, so I'm going to have to close down the line. If others want to continue, I would suggest somebody host another Zoom meeting to have any follow-on conversations. But
Thank you, Glenn.
great conversation, Brian. Thank you so much for stepping in. It was
Yeah,
fascinating.
thanks, Glenn.
Great show.
Thank you so much. Okay. Stay healthy, everybody. Good to see you. Bye-bye now.
Keep your distance.
Oh, we will.